Okay, Dan.
All right.
Take it away.
Thanks, everybody. Let's see here. So iOS development with Swift. A little bit about myself. I first programmed probably in the 80s sometime, similar to John, with BASIC on an Apple IIe, mainly doing like little ASCII art animations and stuff like that. I've been doing software development my entire career since college. And I've specialized in mobile since about 2008, and I've worked with John Hunter several times on different mobile projects. I have many years of Xamarin experience. I first worked with MonoTouch in 2011, and then was doing Xamarin exclusively from 2012 until 2015. So today, what I want to talk to you about is the Swift programming language, in particular, the history, and then give you an overview of the syntax, and then end with a discussion of memory management in Swift and how it's different than Java and C#. And then throughout the talk, I'll be throwing in comments about C#, how C# relates to Swift, how it's the same, how it's different, and at the end I'll throw in some more overall observations that I've had about native iOS development. But first, I want to talk about WWDC. The WWDC is a yearly conference that's held in San Francisco. It lasts a week. It starts with a keynote, and then there's smaller presentations, breakouts that really focus in on different topics, what's new, and sometimes what's old as well. It's been happening since the 90s, but it's become very popular since the release of the iPhone. So in 2008, all 500 tickets sold out, and each year they sell out faster and faster until now. I think maybe they're doing a lottery system. I went in 2012, and I think tickets sold out in about an hour, something like that. So it's kind of crazy. It's kind of fun to experience. So when I went, the line for the keynote was wrapped all the way around the Moscone Center, all the way back to the door, and each side is a block long, so it was crazy. Now in past WWDCs, there's been some major announcements, which adds to the excitement. So just to give you a highlight of a few of them, in 2005, Steve Jobs announced that the Mac would be using Intel processors in the future. That wasn't very popular at the time, so he had some explaining to do. 2008 was the announcement of the App Store. The iPhone launched in 2007, but it didn't have an App Store until 2008. Also, the iPhone 3G was announced. That was the second iPhone, even though it has 3 in its name. In 2010, there was the iPhone 4. iOS got its name. Before that, it was iPhone OS. 2011, iCloud and automatic reference counting, and I'll be talking about automatic reference counting later in the talk. And then, of course, there was the iOS 7 redesign in 2013, when iOS got more of the flat look that we know today. In more recent years, Apple has started to do their big announcements outside of the WWDC, like they're going to do next Monday. But there's still a lot of excitement around it, so it's always fun to keep tabs on what's going on at WWDC. So at WWDC in June 2014, less than two years ago, something pretty extraordinary happened. Let's take a look.
Next, Xcode. Now, Xcode is the tool set we use to build all applications for the Mac and iOS. And Xcode is, in fact, one of the most popular pro apps on our platform. The last version was downloaded 14 million times. It's unbelievable. Now, of course, central to Xcode is the language we use to develop our apps, Objective-C. Now, Objective-C has served us so well for 20 years. We absolutely love it. But we had to ask ourselves the question, what would it be like if we had Objective-C without the baggage of C? Well, we did more than think about it. We have a new programming language. The language is called Swift, and it totally rules. Swift is fast, it is modern, it is designed for safety, and it enables a level of interactivity and development that you've never seen on the platform. When it comes to speed, Swift is great. Compare Python, a popular scripting language, with Objective-C when it comes to something like, let's say, complex object sort. Objective-C is a lot faster, but Swift is faster still. And take something like RC4 encryption, extremely computationally intensive. Python gets utterly crushed in this particular benchmark. But look at Swift. Now, Swift is also modern with features like closures, generics, type inference, multiple return types, and namespaces. You know how many people at home are going, what in the heck are these guys talking about? With Swift, you're able to reduce a common pattern that you might see in your Objective-C code like this and reduce it to something as simple as this. And Swift defines away large classes of common programming errors. They just aren't possible. Now, Swift is completely native to Cocoa and Cocoa Touch. It's built with the same LLVM compiler as Objective-C, using the same optimizer and auto-vectorizer, and it has the same ARC memory management model and the same runtime, which means that your Swift code can fit right alongside your Objective-C and your C code in the same application.
The announcement of Swift in 2014 totally caught everybody by surprise. A lot of time, as Apple's products have become more popular, there's leaks get out, sometimes years in advance about rumors of products, but nothing got out about Swift, even though it was started in 2010. So fast forward to 2015, summer of 2015. I typically watch the videos from the previous year's WWDC because that's about the time I can start using those features. You can't use the brand new features usually. I just find it's easier to do that. So I was watching these videos, and it just occurred to me as I was watching them, it just kind of hit me that I wanted to do iOS development with Swift. Now, the main reason I hadn't done native iOS development was because of an aversion to Objective-C. And now Swift was in version 2.0, so I felt like it was stable enough to be viable. And I started learning Swift. I, just on my own, was going reading books, making sample apps, things like that. And then I was fortunate enough to be placed on an Objective-C project. And my attitude completely changed about Objective-C, because now it was like a history lesson for Swift. Like, I learned about all the things that Swift improves upon. So it was really, really interesting. And since February, I've been working on a Swift-only app, which is really cool. So I've been immersed in Swift for a while, a few months now. So let's talk about Swift history and roots. So this is a chart that I extracted from the internet, so you know that it's got to be accurate then, right? So Swift is heavily influenced by Objective-C, and this shows some of the other influences here. There's probably a lot of stuff that's missing. I just showed direct influences. A lot of programming languages stem from C, and Objective-C, of course, is one of them. The reason that Objective-C is around at Apple is because it was adopted by Steve Jobs' company Next Step after he left Apple. And then when Steve Jobs came back to Apple, the software from Next Step became part of Apple's operating systems. So that Objective-C has been carried along for a long time. Incidentally, the namespace or the prefix NS in a lot of the type names in Cocoa and Cocoa Touch comes from that heritage of Next Step. Stands for Next Step. Because with Objective-C there are no namespaces, so the convention is that you put a 2-letter prefix ahead of your classes. Actually, Apple does a 2-letter prefix. Everybody else does a 3-letter prefix in lieu of namespaces. Let's see. So Swift was also influenced by our beloved C#. And the reason we know this is because one of the main developers of Swift, Chris Latner, had said that these were the influences, along with too many more to mention. So this is the progression of the Swift language, and I show you this just so you realize how quickly it's progressed. It hasn't even been 2 years since it's announced, and it's changing rapidly. That's one thing I want you to keep in mind if you're going to learn Swift, is that videos or blogs or books that you might come across could have things that are already outdated. So just be prepared for that.
Are they actually deprecating features already? Or?
Oh, yeah, they are, and I'll highlight a couple of them as we go. And some of them were just clarifications, like they were things that confused a lot of people, so they would change them. And one thing that's kind of neat about Swift is now that it's open source, we can actually influence it. You can go and make suggestions, and Apple is responding to people's suggestions. So we have influence over its future. So I put in a couple dates here, future dates. Swift 2.2 should be coming out soon. Swift 3.0 could come in the fall. One thing, now that Swift is open source, Apple can't really surprise us because we can just go look at and see what they've been doing. So we know what's coming. So it's kind of rare with an Apple, project like that or product. So next, platforms. So Apple has introduced the Swift implementation on iOS, OS X, Linux, watchOS, tvOS, but it's open to the community to bring to other platforms such as Windows. I couldn't find any confirmation of a Windows implementation, but there's lots of references to it being worked on. So
I think there's one for .NET actually.
okay, I wouldn't be surprised if it happens pretty soon.
Aren't they saying you can? They're hoping that you can use it to write Android apps as well.
I wouldn't be surprised. I hadn't heard that, but
I think I heard that.
So it's moving fast. It's on a lot of platforms. I thought it'd be interesting if Xamarin would extend Swift to the other platforms. I don't know if that'll happen now, but the thought had occurred to me in the past. So what's wrong with Objective-C? Why did Apple need a new language? You can talk to just any Objective-C developer and they can list a lot of things off right away. So it's a strict superset of C, and in that video clip we saw that they said Objective-C without the C. And what they're talking about is Objective-C has the constraint that it has to be able to compile C. Anything that works in C has to work in Objective-C. Objective-C can add more to it, but you can't just change the bit components of the C language that Objective-C uses. So that's a limitation to how it can evolve. Objective-C has a bulky syntax. I think you can find a lot of examples of how rewriting something in Swift just reduce the code significantly. Objective-C requires you to have a header file and a .m file, a body file, so that there's just more bookkeeping type work for the developer. There's the brackets, which come from Objective-C's lineage from Smalltalk. Not a lot of languages use that, so to many developers it's just foreign, hard to get used to. There's dynamic method resolution, which means that you can write code that's going to crash at runtime and the compiler won't catch it. You can send a message which is similar to a method call to a method that's misspelled or doesn't exist. There's no namespaces in Objective-C, as I alluded to with the NS prefix, and heavy use of pointers. So here's, I grabbed this just the other day from that TIOBE index of programming languages. And this shows how Swift just passed Objective-C in popularity, kind of interesting. Objective-C is really falling fast, due to Swift. It seems like Java and the C languages, including C#, are entrenched at the top, but Swift is on its way up. So next I want to give you an overview of Swift syntax. I've got one demo that I'm going to show you after we cover a lot of the syntax. So you're going to see a lot of code, but you're not going to have to watch me type. So we'll start out with variables and constants. So this is a variable declaration in Swift. In this case, the var is different than you're used to seeing in C#. This just means that it is truly variable as opposed to a constant. One thing that you'll notice is that there's no semicolons here. And in Swift, you could put a semicolon there, but it's optional, and it's a good practice not to use those. Semicolons would allow you to put many statements on one line, but it's just not done.
So you've stopped?
It took me a while, but
he's in recovery.
I have finally gotten used to not doing it. So here's an example of concatenating a string, and you can do that with just the plus operator like you can in many other languages, and the print statement to print to the console. There used to be a statement called print ln, and that was deprecated or removed from the language, but if you watch some of the early videos, you'll see references to print ln. Print can do everything print ln did. It has different parameters that are defaulted. So that's basic variables and constants. We'll look at a couple more.
So one thing I like about this is that it has the post type declaration.
Oh,
as
having
opposed to a
the
pre.
type after the variable instead of before it.
Yeah, I actually like that because we had that in ActionScript, which we used to do a lot. And in some ways, it's nicer.
Yeah, it might be more intuitive in some ways. That takes a little while to get used to too, coming from C#.
Question: Does it still compile to C in the back end?
I don't know if it goes through C or not. I suspect it doesn't because they've put a lot of work into optimizing it. So I think it goes right to like some intermediate language that's compiled to ARM instructions. So in this example, I had declared the variables with a var. In Swift, you are encouraged to make things immutable if you can, whenever you can. So Xcode would actually have a warning for you saying, hey, you never changed this variable, make it a constant. So, and that's done with the let keyword. So Swift has type inference, which means if the compiler can infer the type, and we have this in C# too, if the compiler can tell what type you intended, you don't have to put it there. You don't have to include it. So in this case, we can tell these are strings, so the compiler knows that these are strings. So it's not like they're, generic types or something. They're just the compiler figured it out for you. All right, and emoji, which is always cool. So emoji are supported for variable names.
Why would you use emoji for that?
Yeah.
I mean, unless you want to put a middle finger as one, I don't know.
I think that's a terrible idea, actually.
I saw one example where they used the character for pi to represent pi. That was kind of cool.
That's cute.
Yeah. I don't know, once you have the option, now what if you had the convention that every variable had to be an emoji character? That
Oh my God.
If you'd run out of
Some
emojis.
really interesting code
Running
golf challenges.
connections.
Yeah. So I haven't seen much of this yet, but a lot of people like to highlight it because it's kind of funny.
So the thing I find, as we go through here, I've looked at Swift a little bit myself, but I don't know it at all, relatively speaking. And but I find it odd that they make statements like, "We've made it more safe for you to use and make it so you can't make
Yep.
mistakes." But yet they promote practices like using emojis or not using semicolons. I think that contradicts their goal there.
I don't know about that. Like,
Okay.
I would say, I read a statistic, I don't know what it's based in, that like 40% of the runtime errors that you could do in Objective-C won't compile in Swift.
Mm-hmm.
And it addresses those issues. The semicolon, I think the significance of that is that Swift looks at a carriage return. A carriage return is meaningful, and it's not meaningful in the other languages that require a semicolon.
Sure. Okay.
So I don't think that makes it any less safe. And the emoji thing, I haven't seen any examples of people using that. It's just kind of a fun thing that they put in there. But go ahead.
With the emojis, it's not so much variable names, it's that you can put them in strings. It becomes difficult to find like the 10th character of a string though, because it's a Unicode string, so it has to start from the beginning and start counting what type of character it is.
Yeah, that's a good point. I did do kind of a fun app where I displayed emoji in the UI, and it was nice to be able to just paste them into the code, not have to get some sort of delimited code to represent it. So this is an example of type inference. This shows you some of the different data types in Swift explicitly declared, but you don't have to with type inference. So this is showing you that if you have a decimal point, that's inferred as a double. This is obviously a string, this is obviously bool. Without a decimal point, it's inferred to be an integer.
Signed or unsigned?
Good point. I don't know that. Good question. This shows the literal syntax for an array here, and this is the literal syntax for a dictionary. And that came from Objective-C. That was introduced into Objective-C in the last few years. So that's familiar to Objective-C developers.
Dan, what
Yes.
if you did have a long line and you wanted to bring it down, like a long array there?
Oh, right.
Is there a line
Could you wrap
continuation
that?
character then?
In that case, it would be okay. I'm pretty sure it would be okay. I'm not. Oftentimes, you're finding yourself, wrapping things, and it doesn't seem to cause a problem. So,
I know in a lot of other languages that use carriage returns, you use a backslash, and then it lets you carry to the next line. So I think Visual Basic does that.
yep, for line continuation.
I'm not sure either, but in Xcode, when I type a long line, it will split it up automatically.
Yeah, so you often see that. I don't like to do that. I like to just have really long
I do
lines
that
that
in
go off to
C#.
the right.
I bring things down all the time.
But I suspect if you just put a carriage return here, it would still compile. So you're not forced onto one line.
But then how does it know where the real line ending is?
I don't know.
If there's not a semicolon.
I don't know how it does by context, I think.
Okay.
The compiler for Swift has got to be very advanced because some of the, there's a lot of flexibility into the language, which we'll get into. Here I just wanted to point out that there's a lot of operators, you know, that come from the C, it's C heritage, C influence. So that's nice. It makes it kind of familiar to a C# developer, C developer, Java developer. I want to talk a little bit about arrays. This shows a couple different ways to add an item to an array. You have this syntax where it's like adding numbers together, but you're just adding arrays together. Then there's a method for, you know, appending, which is more like Objective-C. To update a value, you just reference it with subscripting, and the value is replaced. Let's see.
So those arrays aren't fixed length?
As long as it was declared with var, it's not fixed length. If it was let, then it would be. So that's the key right there. One interesting thing about arrays and dictionaries, they are value types in Swift. In C#, I got used to thinking of them as not being thread safe because they are reference types. So Swift stresses use of value types, and there's a lot of benefits for that, including you don't have to worry about threading issues as much.
Does that mean they're passed around by value or copy on write?
Copy on write, actually, yeah, good point. Swift implements copy on write. A lot of people in the Swift community are talking about using structs for their data models. You know, and when I thought of that, I thought of how many times I pass a model object around. And I thought, whoa, it's going to be copying all this data all over the place. But the Swift compiler does a copy on write, which means unbeknown to your code, if a value type is being passed around, it's not actually being copied until you change it, and then a copy is made. But logically, you think of it as if copies are being made. You're guaranteed that that it will only copy on a write. That's just a performance enhancement that Swift has.
How do you have side effects, and how do you set value in that array?
How do you set a value in that array?
If it's all copied by value,
right?
The array. How do you change the array?
If you declared
nested in your code.
Right. If you declared it to be var, so that it's variable, then you're able to change. You're able to change it. I'm not sure how it's actually implemented, but when you declare, let me think. Structures, value types are mutable if you declare them with a var in Swift. But one interesting example I can give you to think of is if you had an array of classes, for example, and you made a copy of that, or you passed that around, what you're actually doing is making a copy of references. So the references aren't being copied. The classes in your array are the same classes getting passed around, but the references to them are being copied.
Okay.
So it gets kind of...
Typically, they would encourage you in these languages to create an array. So you pass this to a function, like Groovy and all these things.
Oh, true.
It encourages you to not mutate the state, create an array.
Yeah, you do see a lot of that. Rather than adding an element to an array, you create a new array by adding two arrays together or something like that.
So you end up with a function.
Okay, so here's a function. A function is a self-contained block of code, not within a class. So if it's a global function, that's a possibility with Swift. It seems like Swift is not trying to be strictly object-oriented. You can do object-oriented programming in Swift. It's also a functional programming language, has a lot of functional properties to it. But there's a lot of cases where these global functions are kind of nice.
So is the string there the actual return type?
Yeah, I think this syntax right here is called string interpolation. And this is a way to avoid having to type the plus sign, as I showed before. I had a slide where I was going to talk about this, but I think my little clicker here advanced past it. But this allows you to have, this name right here is compiled. You know, the compiler looks at the string and goes, okay, this is actually a variable. So if you changed the parameter name here and you didn't do it here, it wouldn't compile. So it's just kind of a convenient way to embed, you know, object values or struct values in a string. So you'll see that throughout the other slides. Go ahead.
What's that operator before the return type? Is it just a return operator, or is it the thing that looks like a lambda?
Yeah, the arrow string is the return
okay.
type of the function, I guess.
Gotcha. So this right here means that string is your return type for this function.
Okay.
This, if you don't have anything here, it's assumed to be void or nothing. You can put void in there, but you don't have to.
Are return types also inferred? If you were to omit the arrow string, but yet still return a string, is that inferred?
That would not compile. The only thing that it is inferred is if you don't put anything here, it's inferred to be void or nothing. All right. So we'll be talking about control structures next. This is an if-else control structure, and it should feel pretty familiar, other than parentheses are missing. Parentheses are optional. You can put them in, and when I first started coding in Swift, I was always putting them in. But I've tried to go away from doing that because that's what the preferred way to code is, not to have the parentheses. Another thing about Swift, these braces are required. You can't have one of those statements where if there was only one statement after the else, then you don't include the curly braces. I never liked that. But Swift will not compile unless you have the curly braces, which avoids there's some infamous bugs that happen because of that characteristic of other languages. So this is a for-in loop, and we have something like this, something very similar to this in C#. So this is just iterating through all the elements of an array and printing the integers that are in that array.
So can you go back to that slide? The variable name is index. Are you getting you're getting the value. Okay, gotcha. Because would it be zero-based indexing?
Yes.
Okay.
I think I used a confusing term here in my example. Yeah, good point. Yep, sorry about that. Arrays are zero-based, do have a zero-based index. So that would have been a better name for that would have been value or something like that. Okay, so this is a range, and you'll see this in some other slides too. A range is an object, but it has special syntactic capabilities when you're developing in Swift. So this is just going to return like 1, 2, 3 each time the loop goes through. This is you can think of this as a more modern syntax for the traditional for loop. And the for loop is supported in 2.0. We'll be coming up to that. It's supported in Swift also currently.
Should that actually be a 0 instead of 1?
So this is saying some variable which should have been named value or something like that is going to iterate from 1 to 3 inclusive.
So it's like the range function in Python, except it's inclusive.
Yep, I'm not familiar with Python, but I know Swift was influenced by Python, so I bet that's right. Yep.
Yeah, in Swift you can change like the third dot to a less than symbol, and then print 1 and 2.
Huh. Like that.
Cool.
Yes. So this is the half open range. The other one was the open range. In Swift, when Swift first came out, this less than sign wasn't there. It was either 2 dots or 3 dots, but they thought that was confusing. So they added this less than sign in there just to make it clearly different. Okay. So here's an interesting example of iterating through a dictionary. So we know this is a dictionary just because of this literal syntax with the colon. So this right here is a tuple, actually, or tuple. You know, I've heard both pronunciations. Tuples are used a lot in Swift. C# has them, but they don't seem to have such a prominent role in the language like they do in Swift. This approach, which we'll see in other slides, is called decomposing a tuple. So you're iterating through a bunch of tuples, and then you're assigning the values of those tuples to these variables, and then in the body of your loop, then you can refer to them. Okay, this shows the traditional for loop that you're used to from C-based languages. And interestingly, that's going to be removed from Swift 3.0. People thought that the community suggested this, and Apple has accepted that. The idea is that this syntax would confuse people. It doesn't really match with the rest of Swift, and this can be achieved in more modern syntactical ways.
How would you handle stepping
by twos or
yeah,
threes?
exactly.
Yeah, I know. I wanted to figure that out. There is a way to do it, but I don't have an example of how to do it. I can just tell you that there is a way to do it. Good question. So this is a while loop and repeat while loop. So I just wanted to show you that that exists. We won't go into that in detail because it's pretty familiar.
So the repeat while is a bit like a do while?
Let me go back. Yes, and the reason that it's not a do while is they used do for exceptions or error handling. So they didn't want it to be confused with that. Okay, this is the switch statement. One interesting thing about switch is it does not fall through by default. You don't need a break, which is kind of nice. A lot of defects happen because you forget to put a break in there. Otherwise, it looks pretty familiar.
Can you get it to fall through if you want it to?
You can, and I'll be showing that in a slide coming up. Okay, so this illustrates how you can have multiple values separated by commas. Another interesting thing about the switch statement is your switch must be exhaustive. That means there can't be anything that was missed. So either, like say that you had an enum, you have to have a switch for every possible enum, or you have to have a default. So in this case, we haven't covered every possible character, so there has to be a default. If we deleted this default, then it would not compile.
When you say every possible character, you mean what? 26 letters of the alphabet?
Yeah,
or
good question.
The entire Unicode range of how many thousands of characters?
I would guess the entire Unicode range, but in general, you always need a default unless you have an enum, basically.
Okay.
Or like a Boolean, I suppose, would be another example where you wouldn't need every possible case.
So it would have to be exhaustive over the range of the type.
Yep. Yep.
So every
Well,
possible character that their character set supports, right?
That's right.
So, or a floating type, like you could switch on a double.
Right, and then that's
You'd have to
infinity.
have a default.
Yeah, you have to have a default then. Good point. So here's another.
I'm sorry to interrupt. Can you switch on strings in this language?
Yes, definitely. I don't know that I have an example of that, but yeah. Switch is extremely powerful in Swift, and so are enums. We'll get into that shortly. So this shows switching on a range. Okay, next, tuples. This is the basic syntax for a, wrong. This is the basic syntax for a tuple right here. And if you can also put a name in there, which I'll show you next, but if you don't, you refer to it by its position, like dot 0, dot 1. This is an example of decomposing a tuple. I showed you that before. So you're declaring a variable, which is these two variables assigned to their position in that tuple. And once you've done that, now you can refer to the individual variables. This shows the parameter naming syntax for tuples. So in your print statements, you can refer to the components by their name. Next, I'm going to talk about classes and structs, first classes. This is a basic class definition. I just wanted to point out that there are stored properties and computed properties. The difference between them is a stored property has a backing store, where a computed property is just code that returns some value. So it could be a constant, like in this case, or it could be referring to a stored property, but a computed property does not have a backing store of its own. Now in C#, we would just think of this as a variable, and this would be a property. But in Swift, these are the names that you see for those concepts. Classes have an init method to do any initialization, and the rule with properties is that they must all be set within the init, or else they would have to be assigned up here. You can default the values of a class. So in this case, I've assigned number and initial value within the init, so we're okay. But if I didn't do that, it wouldn't compile. The rules for initializers and classes are surprisingly complicated. In the Swift book that Apple has created, and it's free on iBooks, there's like a chapter on initialization, and it's like 50 pages long. It's really surprising how complicated it is. So I'm not going to go into that other than just to tell, so you know that there's a lot of rules surrounding it. I think it has to do with making sure that once the class is instantiated, there are no undefined values. You know, again, it has to do with Swift's safety emphasis.
And you don't need the init though?
If you don't put in the init, one is created for you, similar to C#. Where it gets really complicated is when you do inheritance. Then, like, each class has to have a designated initializer, and there has to be, at each level, that designated initializer has to be called. And there's convenience initializers. It's not terrible, but it's just kind of different than I'm used to, and it's.
Sorry.
You could do a presentation just on that.
So you're saying the init is the constructor?
Yes, this is the constructor. So, and then to create an instance of a class, it looks like this. It's similar to C#, but you don't need new.
So you either have to initialize the stored property in the constructor or in the declaration of that stored property.
Yes, that's right.
Is there like a shorthand default? It's kind of like in C# you can do the default of a type.
No, like
so you
int
always
is not defaulted to 0, for example, or boolean is not defaulted to false. You have to explicitly do it, or it will not compile.
Is there like a
why is
equals
it
default of boolean or something like that?
Not that I have come across yet.
On the bottom, is that really the variable name, not the type?
I think the sum class is the type. And then
Yeah, naming conventions are a little different than C#. You know, actually, I think that should be it. The convention would be to have a capital S, but that might be what's throwing you off.
About where it says
Initial
initial value. Is that an argument name, or
That is an argument name.
Okay.
So
So
wait.
you have named arguments,
You have named arguments.
and you don't have to. Okay.
Do you have to name the arguments?
Let me think. There is a way that you can, if you don't want to, that you can avoid doing it. I don't think you have that option
Suggested.
in an initializer, though. There are cases where maybe you have like these constructors where you're just building data or objects or something like that, and you're sick of seeing this label there. In that case, there is a way that you can not have named parameters, but that is not the best practice. In an initializer, this word init is not called. You don't see it down here. So the only way to tell one initializer from the other is by its parameters. So therefore, you have to list the first parameter. However, in functions and methods, and I should point out this, even though it says func right there, this is referred to as a method. That's why I put that there. Kind of confusing, but in functions and methods, when you call them, the first parameter is left out typically, other than in an initializer is the special case where you always see the first parameter name. Next, I want to show you a struct, which is pretty much the same thing. Structs are very powerful in Swift, so I wanted to just highlight some of the differences. This keyword struct is different. If you're changing a value within the struct, you have to put the mutating keyword here. That's so that any code that calls that is aware that it's going to change the internal state of the struct. And again, you refer to this as a stored property, computed property. Classes and structs have many of the same abilities in Swift, such as protocols, which are like interfaces, properties, extensions, as we'll be talking about, and the initializers are the same, have the same syntax. A big difference is a struct cannot inherit from anything. That's the biggest difference, and it's a value type. Those are the two key differences.
Sounds very similar to C#'s limitation of classes and structs. Are there differences between Swift and C# in that area?
Can a struct, I'm already starting to forget some things about C#. Can a struct in C# implement a interface? I can't remember. Okay. And let's see what else. Yeah, I think it is the same then.
Do they have the concept of boxing and unboxing?
It is not talked about in those terms, but it is.
I suppose the copy on the right, you kind of need that behind the scenes. Okay.
And we're going to get into optionals, which are probably doing that.
Dan?
Yes?
Did you see anything in there where built into the language to serialize like a state of a class object or anything into string?
I haven't gotten into that yet. The code that I've been working with doesn't seem to do serialization like I'm used to seeing. So I can't say that yet. Right. So access control. Access control is different in Swift. Access control is scoped by the module, which is like the project, or the app, or the framework, and by the file. So if something is in the same file, it's visible to everything else, even if it's marked private. There is no equivalent to protected in Swift, and when I first heard that, I was disappointed because I use protected all the time in C#. But then I realized that when you override a member in a class in Swift, you can change its access and control. So protected wouldn't really have any usefulness because of that.
So you can override a private method?
Yes, as long as you are respecting those scoping rules that I talked about. Like, for example, if something is internal and it's in a framework and you're overriding it, you can't change it because it's internal to that. You couldn't even see it. But if you declare two classes in the same file and you're overriding, one overrides the other, you could change a private method to a public method in that implementation. So yeah, the first thing that goes through your head is you could just, inherit from all these base types, Apple framework and make everything public, but you couldn't do that because of the other scoping rules that are in play. Okay, so this is a really basic enum in Swift. Enums are extremely powerful. This is one of the real interesting and surprising things about Swift. Enums do not have to have a base type to them, but they can. So I'll show you what that looks like. This is what we're used to seeing, something like this, along the line of this in C#. So here we declare the first item within the enum as the number 3, and the Swift compiler assumes that you want 4 and 5 here automatically. So and this just shows an example of printing this out. If you print an enum instance out like this, it's going to print the name of it, the name of the enum. If your enum has a type, then you would have a property called raw value. In the previous example, raw value would not compile, so that's why it's not shown there. But if you have a type, then there's a raw value that you can access, and this shows that the raw value in that case would be 3. Enumerations don't have to be integer-based, they can be strings. So and this shows how we can again print the name of the enum instance or its backing string.
What would it do here if you didn't put square and rectangle on those for the string?
Good question. Oh, I know what it does. It would just take this word right here, and that would become its name. Just copies the name.
Okay.
Yeah, good question. Okay. This is one of the things that was kind of hard for me to grasp at first about enumerations. They can have what's called associated values. So when you create an instance of the enumerated value, you assign that numbers, in this case, to the associated values. And in this case, when we print it out, it's going to look like this if you printed it out to the console. Now, if you have associated values, you can't have a type with the enumeration, so this would not compile. You can't have a raw value in that case. And I'll show you an example of how you can use these associated values in a subsequent slide. Enumerations can have computed properties, not stored properties, and they can also have methods. So that's kind of different.
So the dot circle syntax means down in your method you have return self equals dot circle, or sorry, in your computed property.
Oh yes. Yeah, good point. In Swift, if the enum can be inferred, you don't need to put the first part of it. So in this case, we can infer this, so we didn't have to put shapes there. Good catch. And each one of these examples I actually ran, so I know that it compiles.
Can you access static methods in the same dot syntax?
Could you put a static method in this enum?
Well, let's say, I'm assuming there's static methods in classes. And
Yep.
could you access a static field or stored property or another static method using that same dot syntax?
Yeah, good point. You can access it with the same dot syntax, but you have to reference it with the type name. You can't just call it like you can in C#.
Okay.
That's one, and I hope they change that because it's kind of annoying. Okay, so this is a switch statement with an enumeration. And this illustrates the fall through. If you want to fall through, you have to explicitly say that you want to fall through. So in this case, the new enum only had 3 possible values, so we don't need a default. But if we later added another value, the compiler would not allow it. That's kind of nice to, when you add an enum, maybe you have all these switch statements peppered throughout your code, and the compiler's going to remind you that you need to look at them and update them.
Is there such a thing as a go-to statement like there is in C# within a switch?
I am not aware of that. And this shows again how the beginning of the enum, you don't need to say the name of the enum because it can be inferred by this instance right here. We know this is a shapes enum, so you don't need to repeat it. Okay, this shows us how to get at the associated values within an enum, within a switch statement. So we switch on shape, and then this is another example of decomposing the associated values so that within the case entry you have access to that. Otherwise you can't really get at it. You can't get at this 5 without having some sort of control structure to pull it out. You can't just assign, var circle value equals shapes.circle or shape dot position 0 or something like that. They want you to use associated values within a case statement. Okay. Next, optionals. Optionals are, okay. Well, before I explain an optional, I just want to ask you what you think would happen in this case. This letters is a dictionary, and here we're referencing an entry that does not exist. Now, I know in C# that would crash, right? That would throw an exception. What do you think would happen in this case? Anybody? 24. 0. Well, what would happen is this would be an optional. So it would be set to nil in this case because, did I say int? Yes, okay, that's right. So there is no entry for Z, so it would be nil, a nullable or an optional int. So optionals are central to Swift. In Objective-C, only classes could be nil, and nil was a pointer to nothing. It was a 0. In Swift, nil means something different. It means no value. It's very similar to a nullable in C#. What's different is how important it is to the language. It's just used everywhere. You're aware of optionals all over the place. So this shows use of a nullable, like extending that example from before. We can do an if statement that says if this is nil, then if it's not nil, we can work with it. Otherwise, don't work with it, basically. But this is not the best way to work with an optional because of this right here, this exclamation point. That's called a forced unwrap. And if you do that and this happens to be nil, it crashes the app. So say that you moved this piece of code outside of this check by accident or something. Now all of a sudden you're going to crash the app and the compiler can't warn you about that.
So what is the better way to work with an optional?
Excellent question. Optional binding is one way to work with it. It's the preferred way to unwrap it. So the way this works is if the result of this is not nil, then this position would be set to a non-optional variable, and then you can refer to it without having to force unwrap it. Otherwise, then you fall into the other part of the if statement.
This implies to me that their conditional statements are Boolean only.
Yeah, so this is returning a true or false on whether this got set to a value or a nil. So yeah, the conditional statements are Boolean only. True. So this is another new control statement that was added in Swift 2.0. It's a guard. And the way it works, it's very similar to an if statement. It's just you do a guard and then you do a check. And if that check is true, then you get to go past the guard and run the code that follows it. Otherwise, within the else, you have to exit your current scope. And if you're in a method, that means you have to return. If you're in a loop, in a loop, then you could break or continue or return or throw an exception, or you can crash the app too. But this comes in really helpful with optionals, because in this case, position is unwrapped in all the subsequent code. That's just another technique for unwrapping. Oh, I just wanted to show how you can have many statements in one if let. So here, and they can refer to each other. So here we're saying if the person.employer is not nil, then this would be, not an optional. And then down here, we know that it's not optional, so we can refer to its nullable property, which we can set here, and so on. And this would only get called if all of these things succeeded. So you can cascade things like that. However, a better way to achieve the same thing would be this. This is called optional chaining. This is coming to C#6, something similar to this. With this syntax, we can say if the employer is not an optional, then evaluate the next part of the statement. If address is not optional, then take the city and assign it to this non-optional city variable, and then fall into this code here. If any of those things are optional, then you just go to this part of the control structure. So that's a more succinct way to achieve the same type of unwrapping. This is an example of nil coalescing. If you have a situation where you want an unwrapped optional or a default value, you're effectively doing something like this. You're saying if the optional value is not nil, then force unwrap it, otherwise give me the default. You can do it with this syntax right here, just a little more succinct. Okay, extensions. They're similar to extension methods in C#, but a lot more powerful because they're not one method at a time. You can, and this is becoming one of the preferred ways to extend functionality in Swift as opposed to inheritance and subclassing. You can take somebody else's class and make it conform to your protocol or interface. You can add initializers to it or constructors to it. And you can add computed properties but not stored properties. So you can really customize other people's code, basically. Protocols, which I've mentioned a few times, are very similar to interfaces, so I'm not going to spend a lot of time on them because you just feel familiar when you see them, other than some of the Swift, the new Swift syntax. Very similar to C#. They can be adopted by classes, structs, and enums. Every component of a protocol is required, just like it is in C#, except that Swift has to interoperate with Objective-C. And Objective-C had the equivalent of protocols. It might even be called protocols, I'm not sure. It's been a while. But in Objective-C, the protocol members could be marked optional. And that I know that was challenging for Xamarin. It's trying to map the Cocoa Touch API to deal with these optional interfaces. So in Swift, if you're interoperating with Objective-C, you can put a special keyword in front of your protocol to make it optional. Like we could make do something optional here, but that's not a good idea. It's not considered pure Swift. It's only to interoperate with Objective-C. So protocol extensions are something that there is really no equivalent in C#. What this allows you to do is add an extension to a protocol, not to a class. So in my example here, I have an extension on string for exclaimable. So you can take any string and now you call exclaimable and it'll just add an exclamation point to the end of it. I have a protocol or interface in C# that states that the adopter of this class must have exclaim. Now what I can do is declare an extension on this exclaimable protocol that says anything that is basically a collection of strings can have an exclaim all method. So basically what that means is you can implement something on a whole group of similar type classes, like all collections. Instead of having to override many different types of collections to add your functionality to it, you can add your functionality to a protocol. Okay, closures are contained pieces of code that you can pass around. They're similar to delegates in C#. And I didn't talk a lot about them, or I'm not, because we're running out of time here too. But I just wanted to point out that closures have a lot of flexible syntax, I guess. And so sometimes it's difficult to recognize a closure in Swift code because they're so flexibly described. You can get them down to like just a few characters. You can get them so compact. So that's closures. Swift has generics. It's very similar to C#, so I won't go into detail about it. I just wanted to show you an example of it. Error handling uses a do catch instead of a try catch. There is not a exception class that you have to subclass. Instead, the object that you throw has to implement a certain protocol, and I'll show you that in a minute.
Is there a finally sort of equivalent for the do catch?
There is, and I didn't show an example of it, but one thing that's different about it is that it can appear anywhere. You can define it ahead of time because it's just a closure. This show, a lot of times you do you catch an error and you do nothing with it. This is a more succinct way to write that. I'm not saying that's a good idea, but maybe you're just writing some test code and you don't want to have to do a do catch. What this says is if this is something that could throw an exception or could throw an error, or what we're saying is if it throws an error, return nil, otherwise return the value. So, and with optional binding, we handle that pretty succinctly. So here's an example of an enum that conforms to the error type protocol, and that means that it can be thrown, basically. This is an example of throwing an error.
Sorry, is the error type protocol and just an empty interface?
It is, yeah. That was kind of surprising. There's nothing in that error, in that protocol. So next I was going to talk about memory management, but I see that we're out of time, so that this would be a good time to just end it, because that was my overview of the Swift language and the history. That's a pretty good place to stop. But
you did a great job.
Yeah, thank you.
Well, you have any overall thoughts on
I do.
C#
Let me go
to Swift?
Let me go through this really quick.
For those that want to jump ship now that Microsoft is... Just kidding.
Okay.
Will you make your slides available to the group?
Yes,
Okay.
I
Great.
will make them. For learning Swift, there's something called a playground, which is an interactive way that you can just type in code and get feedback right away. This is like a really complicated version of it, but I use playgrounds all the time. So I just wanted to say that's a great way to learn Swift. Here's a bunch of more information, which I'll give you with the slides. Here's some observations. The MVC, Model View Controller, and Delegate Pattern are very prominent in iOS development. It's hard to fight them. I don't necessarily think they're the best patterns. They lead to really big view controllers, a lot of code in one place. So I really wanted to do MVVM, but it's possible but not widely used. You're kind of fighting against what most people do. There are some initiatives, where people are trying to introduce MVVM to iOS, but it's still pretty early on. Same thing with dependency injection. Data binding, same thing, it's just not widely used. iOS has a lot of references to a method that's done with a string. I'm just not comfortable with it, where actions, like you're saying, when this button gets tapped, call this method, but the way that you reference the method is with a string, so it's easy to break that reference. And I hope that Swift will be addressing some of these problems, because I think that was inherited with Objective-C. Xcode versus Visual Studio, they're very, very different. And you just find yourself kind of lost with Xcode. I think Xcode thinks of what its job is as like a navigator for a big config file, where Visual Studio does a lot more guiding, more like a wizard through things. One example I can give you, Xcode, what you see, what looks like a file structure on the left side of Xcode, it does not necessarily correspond to the file system. It's more build settings. That throws you off for a while when you're used to your project structure corresponding to the file structure. Xcode is free, which is nice. Visual Studio can cost thousands of dollars. Swift is changing really rapidly, so you got to watch out for that. Just keep in mind that you might be trying to compile code or reading, about outdated things that have been removed from the language. I think one of the most complicated things about Swift is just its interaction with Objective-C and its baggage that it brought on from Objective-C, but I hope that that's going to be getting better as time goes on. So that was my observations.
Anybody have any last questions for Dan? So are you happy?
Sorry, I have one. I just thought of it. Sure. What do you miss most about C#?
Think about that. Oh, there are some things. The async and await. I really miss that. Objective-C and Swift do not have a very good way to do, run code on the background thread. So I hope that's something that they improve. Async and await made it so easy that you kind of take it for granted, so to speak. You don't hesitate to do it. With iOS development, you see people aren't very familiar with it because it's complicated and difficult. So a lot of the frameworks that you interact with handle the asynchrony for you. Like you say, you do a lot of passing in a method or some code to be called back on, as opposed to handling it more yourself.
Do they have a baked-in concept of promises or features or tasks or anything like that?
Yes, there's dispatch queues and NS operation, and I've used them, but I don't feel like I understand them very well. NS operation to me seems like the task parallel library. Maybe not as easy to use, but it's very powerful. Like you can do cancellation tokens and things like that. But it seems like C# before task parallel library, like in terms of how complicated it is.
So you mentioned that it's possible to do functional programming in Swift, and you just mentioned passing in functions. So I would infer from those statements that functions are treated like first-order objects in Swift?
That's true. They can be passed around. Let's see, Swift has the map and flat map and functions like that. I was going to point that out, but some of the typical functions that you see in functional programming are there. And so you'll see code that works with that. The first time I saw map, I was kind of surprised, like, what is this doing? But you'll see that a lot in examples, use of map. To do something you could do, you know, with a loop and an if statement or something like that. It's kind of like map and flat map are used like link or lambdas are in C#.